Hi students, in this video we are going to look at the experimental techniques. So don't confuse these with the separation techniques. Okay, the first thing we are going to look for is the solubility and density of gases. Okay, so first of all, we need to know how to collect gases that are produced in the chemical reaction. So we collect these gases based on solubility and density. Okay, so these few are the common gases that we will always see in the lab moving forward. Okay, and then we have their solubility here and the density here. So when we talk about the density of these gases, we are looking at the density comparing it with air, the surrounding air that is around us. Okay, so surrounding air is made up of 78% nitrogen, and then 21% oxygen. Okay, so this is my O2 and then N2. Okay, and then we have 1% other gases, such as your CO2, water vapor, etc. Okay, so the bulk of air is actually made up of nitrogen and oxygen. Okay, so we are going to do a simple calculation to see how dense air is, right? So 78% is 0.78. I multiply it by the relative atomic mass of nitrogen. The nitrogen, if you look at the periodic table, is 14. Because 2 atoms of nitrogen, N2, it will be 28. So I take the percentage, which is 0.78, multiply by the relative atomic mass of nitrogen plus percentage of oxygen, which is 0.21. I multiply it by the relative atomic mass of oxygen, which is 16 plus 16 is 32. Okay, this will give me an approximate value of about 28.56. Okay, so this is the approximate density of air around us, or rather the approximate relative atomic mass of air. Okay, then let's look at each of these gases and we will see. So we have ammonia. By now we have to know it's NH3. I add up all the relative atomic mass, 17 plus 1 plus 1 plus 1. Sorry, nitrogen is 14. So total I will get 17. Okay, so from this value, I can see that my ammonia is less dense than air, right? So that's why we have less dense. Okay, using the same logic, I can go and count the relative atomic mass of all the gases. So HCl, hydrogen chloride, is 1 plus 35.5. Okay, sulfur dioxide, SO2, is 32 plus 16 plus 16. And then CO2 is 12 plus 16 plus 16. Okay, chlorine is diatomic Cl2. This is 35.5 plus 35.5. Okay, oxygen O2 is 16 plus 16. And then H2 is 1 plus 1. Okay, so let's compare this relative atomic mass with air, and then we can see which gas is more or less dense than air. So just now I was looking at the less dense, ammonia, and then I also have less dense, which is my hydrogen. So over here. Okay, so if we look at it, the rest of these gases, based on your calculations over here, are more dense than air. Okay, so based on this density, we have to collect these gases in the experimental setup. We collect it using 3 methods over here. Number 1, we have this downward delivery. So downward delivery is because my gas is collected here at the downside, below bottom, and air gets displaced on top and escapes. Okay, so for this to work, it must be more dense than air. So as it is more dense, the gas that's more dense, it will sink to the bottom. And I can collect it using downward delivery. So all these gases that we just counted, HCl, SO2, CO2, Cl2, right? All these gases, we can use downward delivery. Okay, the opposite is true. We have this upward delivery. Okay, upward delivery, same thing. My gas is on top over here, and the air is displaced over here, this part. Okay, so the gas is collected on top. It must be less dense than air. So we have your ammonia, hydrogen gas as well. Okay, and then we will talk about the solubility in water. So this gas, the one that is very insoluble, is hydrogen. All right, then we have other gases that's slightly soluble. Okay, so these gases, hydrogen, carbon dioxide, oxygen, okay, because they are slightly soluble or insoluble, we can use the method called water displacement. Okay, so in this setup, gas is being produced over here, right? Since the gas will pass through this delivery tube, and then there's water. Since the gases are not soluble in water, I can collect the gas over here because they cannot dissolve in water, they will collect on top. So these three gases are the most common gases that is collected using water displacement.